Welcome to the Corval Group Respirable Crystalline Silica Safety Just-in-Time training module. This module is designed to provide you with the knowledge and information you will need to identify potential silica exposures and the necessary controls to protect workers, as well as how to comply with current regulatory requirements. The objectives of this training module are as follows: defining what silica is, the potential health concerns, changes in regulatory requirements, what constitutes an exposure, potential workplace exposures, methods of protection and compliance, medical surveillance, and stop work authority. Respirable crystalline silica is silica that is in small enough particles that it can be made airborne and inhaled. Respirable crystalline silica particles are at least 100 times smaller than an ordinary grain of sand you might find on beaches and playgrounds. Permissible exposure limit, or PEL, is the amount of exposure an employee can receive over an 8-hour period to a substance or physical agent. Action level is half of the PEL and is the point in which the level of a substance or physical agent is high enough that the employer must take action to reduce them. Resampling of a task or location may be required at 3 or 6-month intervals based on initial sample findings. Employee exposure means the exposure to a substance or physical agent that would occur if the employee were not using a respirator or protective gear. Written exposure control plan is a plan that must be generated before any silica work takes place. It will identify how the employer will reduce employee exposure to the below action level. Assigned protection factor is a classification of the level of protection assigned to respirators. Silica is a primary ingredient in concrete and grout. Examples of activities which may generate a silica exposure can be found below: sandblasting, bushing, chipping concrete, drilling concrete, grinding concrete, mixing dry cementitious grout or concrete, sweeping concrete dust, and activities that produce airborne silica dust. When silica is rendered into respirable crystalline silica, silica dust, it carries with it the potential for respiratory diseases such as silicosis, chronic bronchitis, and lung cancer. There are 3 types of silicosis: acute silicosis, which causes cough, weight loss, and fatigue within a few months or up to 2 years of exposure; chronic silicosis, which appears 10 to 30 years after exposure and can affect upper lungs and sometimes cause extensive scarring; and accelerated silicosis, which occurs within 10 years of high-level exposure. Silicosis is a serious occupational disease that kills approximately 100 people per year. It damages the lungs by creating scar tissue in the lining of the lungs' air sacs, which in turn decreases an individual's ability to breathe. Over time, the lungs' capacity decreases to the point where some individuals may need support with oxygen and other devices to help them breathe. Imagine if you were to take a piece of 400 grit sandpaper and run it once across the top of your hand. Very little would happen. Take that same piece of sandpaper and rub it across the top of your hand 20 times a day for a period of time. A thick callus would develop. This thick callus is comparable to what occurs to the lining of the lungs' air sacs with prolonged silica exposure. Due to the nature of the damage to the lungs, there is no cure. This is why prevention is so important. The most prominent change to the silica standard was the reduction in OSHA permissible exposure limit, PEL. The revised OSHA PEL for silica is now 50 micrograms per cubic meter. This reduction in the PEL also means a reduction in the action level, which is the level in which employers must take further action to prevent exposure. Another change to the standard is the requirement for a written exposure control plan. These plans must identify items such as a description of the task, a description of control methods to limit exposure, and a description of the procedures used to restrict access to the work area. In addition to these changes, OSHA also included changes to the requirements for a medical surveillance program as it pertains to silica exposure. How much of an exposure can drilling holes in concrete cause? If we drill 4 3/4-inch holes at 6-inch depth, we remove 10.6 cubic inches of concrete, which is 300 grams. On average, concrete is 50% silica. 50% of 300 grams of concrete dust equals 150 grams of silica. 150 grams converted to micrograms is 150 million micrograms. The OSHA PEL for respirable crystalline silica is 50 micrograms per cubic meter per hour, not exceeding an 8-hour day. While this exposure is hypothetical, it does illustrate how much silica can be produced by even the smallest of tasks. The following activities and tools may create an exposure and are commonly found on construction sites: stationary and walk-behind masonry saws, handheld saws for cutting masonry, handheld and mounted core saws and drills, jackhammers and other chipping tools, any type of grinder for mortar, concrete removal, demolishing, abrading, or fracturing silica-containing materials, any activity that may generate silica dust. It is important to keep in mind that it is not just the work that we do that can create an exposure. We must also protect our workers from exposures that others create. Table 1 was introduced as an appendix to the OSHA standard as a way for construction companies to be in compliance with the silica standard. It covers most construction tasks that have the potential to create a silica dust. The first step is to find the equipment or task in column 1 that identifies the work you will be performing. Column 2 will help determine the engineering and work practice control methods to prevent an exposure. There are typically differences when the work is to be conducted indoors as compared to outdoors. Column 3 will help determine what respiratory protection will be required, and this will depend on how many hours during an 8-hour work shift the employee will be performing the task. This section will indicate what respiratory protection is required. Respiratory protection with an assigned protection factor, APF, of 10 is required, or respiratory protection with an assigned protection factor, APF, of 25 is required. The project's site-specific safety plan should include Table 1 and a plan around your tasks creating silica dust. Projects that do not have a site-specific safety plan shall reference Section 1A of the THA and contact safety prior to performing any activity that has the potential of creating silica dust. Within Table 1 and the standard itself, you will see a control that is essentially removing the exposure by eliminating the respirable dusts. Two prominent methods are the wet methods and use of a HEPA-rated vacuum with appropriate attachments to capture and filter the dust. The photo on the right shows the drilling being performed through an ancillary shroud that collects the air and dusts at the point of impact. The shroud will typically have a fiber or whisker component that allows a range of drill bits to be used and will not be completely consumed with each drilling task. Anytime a visible dust is still being created after the application of mitigation equipment is a stop work authority situation. The hazard is not being controlled and the exposure is happening. Simply put, just having the equipment is not enough. It has to be working effectively. This image illustrates options from a different manufacturer with a larger body tool. The vacuum needed and shown in the background of the top photo is not a typical shop vac. It must be HEPA-rated and usually incorporates fleece into the collection bag so it can effectively filter the output air. This tooling is not battery-powered. It will collect the respirable dusts, but will allow the larger portions of debris to fall away. The larger debris will not generate a respirable hazard, but should be moved out of the way while the dust is being collected, if it can be done safely. In various scenarios, this is the best option when a wet method will not work. Remember that if you do go to a wet method, the importance of a GFCI in the electrical source line. This image illustrates options from a different manufacturer with a larger body tool. The vacuum needed and shown in the background of the top photo is not a typical shop vac. It must be HEPA-rated and usually incorporates fleece into the collection bag so it can effectively filter the output air. This tooling is not battery-powered. It will collect the respirable dusts, but will allow the larger portions of debris to fall away. The larger debris will not generate a respirable hazard, but should be moved out of the way while the dust is being collected, if it can be done safely. In various scenarios, this is the best option when a wet method will not work. Remember that if you do go to a wet method, the importance of a GFCI in the electrical source line. This slide shows the options with using a wet method to control the generation of silica dust. The key phrase with wet methods is point of impact. It is not compliant to flood an area with a garden hose and then start breaking or chipping. The water must be applied at the point of impact. That is where the tooling meets the concrete. The water application can be done by another employee who is dressed in the same level of PPE as the employee operating the tool. On occasion, providing water to a construction site can be a challenge, but simply cannot be overlooked if it is required for silica exposure. This may bring forward another opportunity to use stop work authority. Many long-standing larger tools have always used water as a means of lubricant and to cool the tool attachment, blades, discs, etc. They have somewhat removed the dust issue before it was an issue. However, the same tools cannot be used dry under any circumstance, and there will always be a slurry left over. As this slurry dries, it can form a secondary exposure to anyone cleaning it up. Dry sweeping is forbidden by the OSHA standard and replaced with HEPA vacuuming. We will cover this further in a few slides. A written exposure control plan must be in effect anytime employees will potentially be exposed to respirable crystalline silica. A written exposure control plan must contain the following elements: a description of the engineering controls, work practices, and respiratory protection to be used to limit employee exposure. A description of the housekeeping measures to be used to limit employee exposure. A description of the procedures to restrict access to the work area. This is to minimize the number of employees exposed. This plan must be approved by your supervisor prior to the start of work and may already be identified in the project's SSSP. The overall plan will designate a competent person to oversee the silica operations. OSHA no longer allows for the dry sweeping of silica dust. Dry sweeping not only puts the worker involved at risk, but any other person in the area, as dry sweeping creates high airborne silica concentrations. Ideally, tools equipped with integrated dust extraction systems should leave very little silica dust after the activity is completed. Should silica dust removal be required, an approved method should be used, such as sweeping with a sweeping compound or vacuuming with a vacuum equipped with a HEPA filter. A cleanup method should always be listed on the task's exposure control plan. As part of the OSHA standard, they have provided a Table 1 in the appendix. The construction industry has taken this several steps farther and included pictures to assist with the decision-making process when using methods to control silica exposures. This slide shows a sample of Table 1 as generated by the industry and not OSHA for simplicity. Understanding the Table 1 guidance and limitations may require a meeting with your supervisor to be sure we are meeting the compliance expectations. Understanding how to read the table is very important to ensure no one is exposed. Choosing the right respirator, if required, is critical to control worker exposure and ensure compliance with regulatory requirements. If Table 1 indicates that respiratory protection with an APF of 10 is required, workers must use a half-face respiratory with a P100 filter at a minimum. If Table 1 indicates that respiratory protection with an APF of 25 is required, workers must use a loose-fitting powered air-purifying respirator, PAPR, at a minimum. Corval recommends the use of a half-face respirator when an APF of 10 is required, and a full-face respirator when an APF of 25 is required. It is important to note that Corval does not allow the use of disposable filtering face pieces. You must contact safety to be fit tested for a respirator prior to wearing a respirator. All employees who are required to wear a respirator for 30 days or more per calendar year must be enrolled in a medical surveillance program. This program shall consist of baseline exams within 30 days of assignment and a periodic exam at least every 3 years or more frequently if recommended by a doctor. Exams must emphasize on the respiratory system and must include the following: medical history, a physical exam, a chest X-ray, a pulmonary function test, testing for latent tuberculosis infection. If a respirator is worn for protection against respirable crystalline silica, the number of days that the employee wears the respirator must be tracked. Employees must be enrolled in a medical surveillance program prior to having worn the respirator for 30 days. If you or one of your employees will be required to wear a respirator for silica exposure and suspect that it will be worn for 30 days or more, please contact your safety manager. Over my professional career, I have seen many incidents that occurred because someone wasn't comfortable telling a coworker that what they were doing was at risk. At Corval Group, we expect this critical behavior every time an opportunity arises. We call this our Stop Work Authority. All employees and subcontractors are empowered, authorized, and obligated by our owners, myself, and leadership of Corval Group to stop work at any time for any unsafe condition. All employees and subcontractors are expected to stop working until the safety hazard or quality risk has been resolved. This stop work authority can be difficult for employees to embrace because of the fear of losing their job. Be assured that no employee will ever be penalized for using stop work authority. Thank you for participating in the Corval Group Just-in-Time Training Module. Contact your regional safety manager with questions, comments, or concerns.